Yeah, okay. So I started recording already. Okay. So let's take a look at the right angle triangle. Okay. So for trigonometric ratio of acute angles, right, it only applies for right angle triangle. Also, this is something that you must know. And when we are labeling a right angle triangle, I always start with the longest length of the right angle triangle, which is the hypotenuse. Okay. So in Pythagoras theorem, you'll remember, right? Where's the hypotenuse? Okay, let's say length 1, length 2, and length 3. Which one is the hypotenuse?
Length 3.
Length 3, right? Oh, Charlotte, you understand?
Yeah.
Okay, so this one is the hypotenuse, and we can label it as H. Right? Now, the other two lengths, right, it will depend on where our mark angle is. Okay, by meaning of mark angle, it means that usually the question will say, find the trigonometric ratio of angle A. Let's say I call this angle A. Then find the trigonometric ratio of angle A. So this angle A is called a mark angle. And when we have a mark angle, right, then the other two lengths, they are also labeled a certain side. Okay, so the side that is facing the mark angle, we will call this the opposite. So this will be the opposite. And then the side that is, okay, maybe I don't call this A lah, then it's a bit confusing. I call this X. So the side that is that's just beside angle X, just beside angle X, this will be called the adjacent. And then we will have all our sides labeled, the opposite, the adjacent, and the hypotenuse. Right? So how do we label a right angle triangle? Right? We always start off with the longest length, or the hypotenuse. So the hypotenuse is always the length that is facing the 90 degree. That's how we first label. Then after that, we will just label the remaining two sides. The remaining two sides, right, the opposite will be the length that's facing the mark angle, right? And then the adjacent is the length that is just beside the mark angle. Okay, because if you understand the English word adjacent, right, adjacent means beside each other. So that's why it's beside. Opposite means facing. So that's why this is how we label. Are you clear about this?
Yes.
Can? Yeah, okay. Okay, let me give you another example. You try and label the triangle. Yeah, so let's say I have a mark angle here now. Okay, I call this mark angle Y. Okay, so where is your hypotenuse? Length 1, length 1, length 2, or length 3? Length 1, length 2, or length 3? Where's the
Length
hypotenuse?
3.
Length 3, right? Charlotte, you understand?
Mm.
So this one is the hypotenuse. So we label the hypotenuse first. Okay, next we want to label the opposite. Okay, so length 1 or length 2. Which one is the opposite? Length 1 or length 2? Charlotte?
Length 2.
Length 1. Length 2. So this is the opposite. Okay, and then finally the adjacent. This one will be the adjacent since it's the remaining length. So that's how we label the sides of the right angle triangle. Are we clear about this?
Mm-hmm.
Yeah. Okay, so this is basics. So you're very clear about this already, right?
Mm-hmm.
Okay, let's look at the trigo ratio now. Now, trigo ratio, right, there are three parts of it. Okay, so first is tangent, so we call it the tua lah. Okay, then cosine we call it the ka, and sine we call it the so. So tua ka so. Yeah. So this one is actually a Hokkien word. Hokkien word meaning Bigfoot auntie. Tua T-O-A, ka C-A-H, so S-O-H. So this is actually meaning Bigfoot auntie as a Hokkien language. Right? Okay. Specifically, how do we use the formula? Okay, so you see T here, it means tangent theta or tangent X. Okay, we call this theta. Theta is like an I like that. It's a big O with a stroke in the middle. This thing is called theta. Theta is a symbol representing angles. Okay, so this thing. So T represents tangent theta. Tangent theta equals to opposite over adjacent. So this is the formula, right? Okay, same thing for ka. So what is it? Cosine. So it's cosine theta equals to adjacent over hypotenuse. So this is the formula for cosine, right? And then lastly, the sine formula. So sine theta equals to opposite over hypotenuse. So this is the formula for sine theta. Okay, are you clear about this? So you can actually write this as a short form lah. Okay. I know in the video in SLS, right, the formula was very long, then very lengthy, right? So you can write the short form to help you remember. Also, toi, ka, so. So if you remember these acronyms, right, then it's easier for you to translate it into the formula. Are you clear about this? Yeah. So basically, these are the main learning that we have done today lah. And to apply the formula, right? Okay, that's how we apply the formula. So let's look at some examples now. So let's say I have a triangle. Okay, and then my mark angle is here. My mark angle is x. Okay, I tell you that the triangle has a value 3, 4, and 5. Right. So if the question asks you what is the value of tangent x, so first you must remember the formula first. What is the formula for tangent x? So we go back to the formula here. The formula toi ka so. Which one is the formula for tangent x?
Is it the opposite over the adjacent?
Correct. Good. Good question. Okay. So opposite over adjacent, right? So from here also same thing. Tangent x is opposite over adjacent. So we will write down the formula. Okay. After this, we will need to label the triangle. So if you look at this triangle, we always label the hypotenuse first. So which one is the hypotenuse? 3, 4, or 5?
5.
5 is the hypotenuse. So you can label as a hypotenuse, right? Okay. Then 3 is which side? Opposite of or adjacent?
Opposite.
Good. Opposite, because it's facing the mark angle. Then 4 is opposite or adjacent?
Adjacent.
Good. Good. Adjacent. Yeah. So once we have labeled the triangle, then we can use the formula. So the value for tangent x will be equals to?
4.
No. Okay. O over A, right? So what's the value of O?
3 over 4.
Good. Excellent. Yeah. So the value of tangent x will be 3 over 4. Okay. So notice tangent x is in the format of a ratio or fraction. Okay. That's why the title is also called trigonometric ratio. That means we always expect our answer as a fraction. Okay. Yeah. It cannot be a whole number. It cannot be it cannot be a whole number. It must be a fraction. Can we understand that? So for trigonometric ratio is always in the form of a ratio. Okay, can? Yeah, okay. So this is an example for tangent x. Let's look at sine x and cosine x. In fact, we can go back here. Yeah, okay. So for the same triangle, okay, what will be the value of cosine x? What will be the value of cosine x?
4 over 5.
4 over 5 are good. Okay, so cosine x, we use the formula is a over h, and then you'll get 4 over 5. Charlotte, you understand? Charlotte?
Yeah.
Can okay. Okay, then the last one. So the last one will be your sine x. Okay. So what's the formula for sine x? What's the formula for sine?
5.
3 over 5. So the formula is O over h, right? Then if you apply the formula, it's 3 over 5. Okay. Are we clear about this? Okay. Now, if I change the question now, I'm using the same triangle, but I'm using y here now. Okay, if I use y here now, do you think the sides of the triangle will change? Do you think the label for the sides of the triangle will change? If I use y now?
Oh, yes.
Yes, okay. So be very careful. So when your mark angle has changed, right? Because sometimes within the same question, they can have a mark angle here, they can also have a mark angle here. Right? Now, under a situation where the mark angle has changed, right, do not label your triangle on the same diagram. Okay, I will advise you to draw a new diagram. You understand what I'm saying? That means if your mark angle is on a different side, do not attempt to label the sides on the same triangle. It will confuse you. Okay, so what we should do, we should start off with a new diagram and you relabel the whole triangle again. Are you clear about that? So let's take a look at it now. So now I'll redraw the triangle, but this time we are looking at the mark angle y. It's the same triangle, just that now we are looking at mark angle y. Okay, so again, we need to relabel the triangle again. So which one is the hypotenuse?
It,
5.
5, okay, the hypotenuse is 5, good. Which one is the opposite?
4.
4, good. Yeah. And which one is the adjacent?
3.
3, okay, excellent. Yeah. So notice if we compare with the previous diagram, previous diagram 3 was a O, but for the current diagram 3 is a A. So there is a difference when your mark angle is different. Can you notice the difference?
Yes.
So it's very important that we actually redraw a diagram instead of labeling on the same diagram, because if you label on the same diagram, it will be very confusing. Are you clear about that?
Mm-hmm.
Okay, yeah. Okay, so now we do the same thing. We want to find the trigo ratio. All right, so what is sine y? What will be the value of sine y? What do you think is the value of sine y?
4/5.
Good. Okay, 4/5 O over H, and then you get 4/5. Okay, cosine y. What's the value of cosine y?
3/5.
Good, good. Yeah, good. Charlotte, you understand Because you are not responding, I don't know whether you understand. Okay. Then the last one, tangent y. Okay, tangent y, what's the formula?
4/3.
4/3, excellent. O over A, which is 4/3. Okay. Now you look at all the 3 numbers. Which one has a ratio more than 1?
4/3.
4/3, which is tangent. So only tangent can have a trigo ratio that is more than 1. For sine and cosine, it's impossible to have a trigo ratio that is more than 1. Do you know why? What is the reason? Do you know what's the reason? For sine and cosine, it will never have a trigo ratio more than 1. But for tangent, it may have a trigo ratio more than 1. Any ideas for what is the reason?
Is it cause
Okay, you have to.
the
Is it what?
hypotenuse?
It's the hypotenuse.
Yeah.
Correct. Good. Yes. Kai is very observant. Okay. Charlotte, you understand what Kai is suggesting? Charlotte?
Yeah.
You okay? Okay, let me explain one more time. Okay, because if you notice for sine and cosine, they are divided by the hypotenuse. And what do you understand by the hypotenuse?
It's the longer side of the
It is the
triangle.
longer side of the triangle, correct? Okay, so will there be a situation where it can be longer than 1? I mean, the ratio can be bigger than 1? Because the numerator will be either the hypotenuse. I mean, worst case situation is hypotenuse over hypotenuse, correct? But it's either opposite over hypotenuse or adjacent over hypotenuse. It can never be hypotenuse over hypotenuse also, correct? So under this situation, will the trigo ratio for sine and cosine ever exceed 1?
No.
It will never exceed 1, right? Because it's divided by the hypotenuse. Can we observe that? So if it's divided by the hypotenuse, the longest length is already the hypotenuse. So it will never, the numerator will never be a number that is bigger than the denominator. And because of that, right, the ratio for sine and cosine will never be more than 1. That's the reason why. Can you understand? So that's basically the idea. And that's all for today's learning.
Okay.
Can we get that? Yeah, okay. So with this understanding, you all try and re-answer the questions.
Okay.
Okay? Yeah.
Thank you.
Yeah, thanks.
Thank you.
Bye-bye.
Yeah, bye-bye.